Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dr. Junior, your math tutor. In my today's lesson, I will be discussing integral calculus. And under integral calculus, I'll be looking at one of the methods involved in solving integral calculus, that is integration by parts. So in previous lessons, we solved like 3 problems involving integration by parts of different cases. And we want to look at a kind of different case for this one, the case wherein you have an exponential function being multiplied by a trigonometric function. So whenever the exponential function is being multiplied by the trigonometric function, that case is always a repeated case, whether it is e raised to the power x sine of x or e raised to the power 2x cos of x. As long e and cos, e and sine is being multiplied, that is a repeated case. So what you do is start by first substituting. So let the integral of e raised to the power 5x cos of 2x dx be equals to some r. So that if this identical integral repeats, you can be able to substitute it with r and find the solution. So when you have the integral of an exponential function and a trigonometric function, for this you cannot easily say, I will always make u to be my e and my, the u to be my this. It doesn't matter, right? So whatever you want to make your u, you can make it your u. Whatever you want to make your dv, you can make it your dv. So for this problem, I'm going to select having my u to be the exponential function. So I say let u equals e raised to the power 5x. So the u now will be 5 e raised to the power 5x dx. Then my dv, the portion I'm integrating, will just be equals to cos of 2x dx. So if I integrate both sides, I'll get v now to be, now this is 1 over 2 sine of 2x. Then come back and say integral of e raised to the power 5x, that is our u dv. U is e raised to the power 5x. dv now is cos of 2x dx is just equal to uv. This is u and v, so it's like 1 over 2 e raised to the power 5x times sine of 2x, so it's uv, minus the integral of v. V is 1 over 2 e raised sine of 2x du. There is du. So I'm going to, in fact, I can just have like 5. So let me put it so you understand it. So it's sine of 2x times 5 e raised to the power 5x dx. So remember, this entire portion now is just my r. So I'm going to rewrite it as 1 over 2 e raised to the power 5x sine of 2x minus 5, and this I can bring it outside. The integral of e raised to the power 5x is 5x sine of 2x dx. So again, I say let my u be equals to e raised to the power 5x, and then my du now equals to 5 e raised to the power 5x dx. And then let my dv equals to sine of 2x dx. So my v now will be minus 1 over 2 cos of 2x is my dv. So when I put it in, I'm going to get the first one is r equals to 1 over 2 e raised to the power 5x sine of 2x minus 5 over 2. So right here now is going to be this expression uv. What is my u? My u is e raised to the power 5x times v. V is minus 1 over 2 cos of 2x minus the integral of v minus 1 over 2 cos of 2x times du. Du is just 5 e raised to the power 5x. 5 e raised to the power 5x dx. So I have r now to be 1 over 2 e raised to the power 5x sine of 2x, so I can multiply. So this time this will give me positive. So it's 5 all over 4 e raised to the power 5x cos of 2x. So this and this is positive. This is 5 times 5 is 25. Is 25. Then 2 times 2 is 4. So I'm going to have the integral of e raised to the power 5x cos of 2x dx. So what do you observe? E raised to the power 5x cos of 2x. This is already my r. So I'm going to say this is 1 over 2 e raised to the power 5x sine of 2x plus 5 over 4 e raised to the power 5x cos of 2x minus 25 over 4 r. So that is my r. So I can multiply this entire expression now by 4 to get rid of the 4. So we have 4r is equals, now 2 goes into 4 2 times, so it's 2 e raised to the power 5x sine of 2x. So 4 and 4 cancel. I will have 5 e raised to the power 5x cos of 2x. 4 and 4 also cancel. I will have minus 25r. Then I can say plus some constant c, or at the end I just write plus some constant c. So I can simplify. This r can come across. It becomes 4r plus 25r equals to 2 e raised to the power 5x sine of 2x, and then plus 5 e raised to the power 5x cos of 2x plus some constant c. So 4 plus 25 now is 29r, or equals to 2. Now, e raised to the power 5x and e raised to the power 5x can be factored out. So I will have e raised to the power 5x, and then here is 2 sine of 2x plus 5 cos of 2x plus some c. So now I can divide both sides. Divide this out by 29, this out by 29. Leave the c out. So r now, this r, I know my r is the integral, so I can just replace it with the integral of e raised to the power 5x cos of 2x dx to be equal to e raised to the power 5x over 29 times 2 sine of 2x plus 5 cos of 2x plus some arbitrary constant c. So this is how we integrate the integral of e raised to the power 5x cos of 2x dx. So remember I told you this is a repeating process. This will always repeat. So whether you have e raised to the power ax cos of bx, is going to repeat. So thanks also much for watching, and see you in our next video. Thank you.